Okay, we're going to go through the Unit 9 problems off of the review in detail. It's going to be 10 through 14. There's a good bit here. So if you do have any questions we go over, you can always email me and I can try and do a Google Meet, or we can do something to fix them. But you have to know these problems. If you don't know them, either see somebody or email me. All right, so for number 10, you got here for the polynomial f of x equals 3x to the fourth minus x cubed plus 4x minus 2. Find the following. F of 4. All that means is we're going to plug in 4 into the polynomial. So it's 3 times 4 to the fourth power minus 4 cubed plus 4 times 4 minus 2. Now, you could actually just plug this whole thing into your calculator if you wanted to and get your final answer, or you could go piece by piece. So you could take 4 to the fourth power and take that times 3. So you're going to get 768 for the first part. Minus, well, 4 cubed is going to be 64. 4 times 4 is plus 16 minus 2. And then 768 minus 64 plus 16 minus 2 gives me 718. So that means f of 4 equals 718. F of negative 2. Let me just put that one over here. You just got to be careful when you plug in a negative, when you're squaring it or cubing it, especially when you just plug it in your calculator. So that's 3 times negative 2 to the fourth power minus negative 2 cubed plus 4 times negative 2 minus 2. Negative 2 to the fourth power. Negative 2 times negative 2 times negative 2 times negative 2. 4 negatives is a positive. That's going to be 16. 16 times 3 is 48. Minus negative 2 cubed, that's going to be negative 8. So minus a negative becomes plus 8. Plus 4 times negative 2. Whoops. That's going to be 4 positive 4 times negative 2 is minus 8 minus 2. And so f of negative 2, 48 plus 8 is 56, minus 8 takes us back to 48, minus 2 is 46. If you do type that in, make sure you put negative 2 in parentheses when you take it to the powers, minus negative 2 to the third power plus 4 times negative 2 minus 2. As long as you type it in right, you're going to get it right. So f of negative 2 is 46. Number 11, long division. To find the quotient and the remainder for 6x cubed plus 11x squared minus 28x plus 15, all divided by 3x minus 2. So I'm going to divide 3x minus 2 into 6x to the third plus 11x squared minus 28x plus 15. If you are missing a term, you have to put a 0 in that spot. So if we were missing x squared, it did not have an x squared, you would put in 0x squared to hold that place value. Otherwise, things are going to get jumbled and confused. This is a complete polynomial. We have x cubed, x squared, x, and a constant, so we're good. All right, long division. 3x, you just worry about the 3x in each of the first terms. Well, either what times 3x or how many times does 3x go into 6x cubed? I like to think multiply. 2x squared times 3x gives me 6x cubed, and then 2x squared minus 2 gives me minus 4x squared. And when you do long division, you subtract. You need to put that in parentheses. 6x cubed minus 6x cubed, we always want that to be 0. And then that's going to be 11 minus a negative. So you got to be careful that that's going to become 15x squared. Bring down the next term. But we're only concerned about the 15x squared and the 3x. What times 3x gives me 15x squared? It will be plus 5x. 5x times 3x is 15x squared minus 10x. When you subtract, 15x squared minus 15x squared is 0. Negative 28 minus a negative, so that becomes a plus. So in the end, that's minus 18x plus 15. We keep dividing until the degree of the remainder is less than the degree of the divisor. If they're equal, we keep going. What times 3x gives me negative 18x? Minus 6. Negative 6 times 3x is minus 18x. Negative 6 times negative 2 is plus 12. Subtract that whole thing, and that ends up giving us 0 for this piece, but I get 15 minus positive 12, which is 15 minus 12, which is 3. That's a constant. That degree is less than 3x minus 2, so that means we're done. Your quotient, so our answer is 2x squared plus 5x minus 6. And then we always take our remainder and put it over the original divisor, which is 3x minus 2. Okay, so that's your answer there. If they ask for the pieces individually, the quotient would be 2x squared plus 5x minus 6. The remainder is 3. Typically I'm going to have you just put it in that answer format there. So that's long division. You have to use long division if there's a number in front of the x. If there's no number in front of the x and you have a linear term there, x plus 2, we can use what's called synthetic division, which you learned about. Again, we want to have it in descending order. We want to have a complete polynomial. If you're missing a variable term, you put in a 0. We have x to the 4th, x cubed, x squared, x, and a constant, so we are good. When we do long division, if it's x plus 2, we put minus 2 out in front, and I list the coefficients of each term. And I'm going to start it off with a 0. They might have taught it to you a little bit differently, but in the end, it'll be the same. And you always add vertically. So 3 plus 0 is 3. Multiply the answer by the number in the box to get the next number here. So that's negative 6. 4 plus negative 6 is negative 2. Negative 2 times negative 2 is 4. Negative 6 plus 4 is negative 2. Negative 2 times negative 2 is 4. I get a negative 3. I get a positive 6. And I get an 8. That last number, I like to kind of separate it, is always your remainder. So this part here is the quotient. This is the remainder. This is always 1 degree less when you use synthetic division. So the answer is 3x, and that started out as x to the 4th. That's going to be x cubed minus 2x squared minus 2x minus 3 plus 8 over x plus 2. Okay, I prefer this format. If you're ever asked what the quotient is, that's just going to be 3x squared minus 3x cubed minus 2x squared minus 2x minus 3. And then our remainder is 8. Okay. Number 13. All right, there's a lot to this problem. We're going to go through it. You are allowed to use your graphing calculator for the whole thing, and I'll explain how this will help you in a problem like this. Now it says find all zeros, real and complex. A complex means it could have an I in it. So you could have a zero of 2 plus 3i. And if we have 2 plus 3i, you got to have 2 minus 3i. So those are possibilities. These steps are to help organize the problem and to help me see your work. All right, possible roots. You got to be able to do this. For possible roots, that deals with the coefficient, which is a 1, in front of the highest degree term and the constant. And what we like to do, we call that one A and we call this one B. You may have done it differently in your class, which is fine. But the possible roots are all the combinations of B over A. All right. Well, A are all the divisors of 1. And the only divisors of 1 are plus or minus 1. B are all the divisors of 6. Well, 1 divides 6, 2 divides 6, 3 divides 6, and 6 divides 6. And so our possible roots are in the form B over A. Now, since A is just a 1, you are taking each one of the numbers in B. So you're taking 1 divided by 1. You're taking 2 divided by 1. You're taking 3 divided by 1. And you're taking 6 divided by 1. Well, since it's just a 1, you end up with all the constants. So the possible roots are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Yes, you do need to include the plus or minus because it could be a positive 1 or a negative 1, a positive 2 or a negative 2. Now here it says test the roots using synthetic division until you find one that produces a remainder of 0. So what you can do is let's take 2, and I'm going to test that by using synthetic division, which is 1, 2, negative 23, and 6. And I use synthetic division to see if I get a 0 at the end. Hold on here, let me make that a little nicer. So you add here, you multiply. 2 plus 2 is 4. 4 times 2 is 8. Negative 23 and 8 is negative 15. Negative 15 times 2 is negative 30. My remainder is negative 24. We want it to equal 0. It doesn't equal 0. Now, you could keep guessing until you get a 0. But since you are allowed to use the graphing calculator, what you can do, and this is what I would recommend you to do, and I would tell you to do this, is you plug in this equation and see where it hits the x-axis. So we're going to plug in x to the third plus 2x, I can just hit x squared, minus 23x plus 6. And I'm going to hit graph. Now it hits 0 at 1, 2, 3 spots. Those are our 3 roots which we have to identify. I'm going to hit second calculate, 0, and I'm going to go over here and see what this root here is. All right, see where it's just above there. I go to the left. Even though I lose sight of it, I'm going to hit enter for my left bound. Right there is going to be my right bound. And guess comes back negative 6. All right, that means that's one of my roots. I'm going to go test this other one. Second calculate, 0. I lost sight of it. Wait, I'm going the wrong way. Sorry. Okay, see it right up here? That's my left bound. I'm going to hit enter. And I'm going to go a little bit past it, and I'm going to hit enter again. Okay, you get a decimal. Okay, that means that that root is irrational. It has to have a radical. You cannot just round that off. I want the exact answers for your problem. I don't want any rounded off decimals. I also know the other one's going to be irrational, so I'm not even going to check it. I know that because they have to come in pairs. Once you find one root, if it's third degree, we can go to that. So -6 is a root, and you're going to have to do this so we can find the other two roots. So -6, I got 1, 2, -23, 6. Put in a 0. 1 times -6. Add that to get -4. Those multiply to give me 4. 1 times -6 is -6. You get a 0. So what that means at this point, that means if -6 is a root, x plus 6 is divisor, and specifically x plus 6 times x squared minus 4x plus 1. So one thing you got to know is x equals -6 is a root. If it's third degree, that means there's 3 total. We got one of them. Well, what we do now is we use, as you take a look at part C, use the quadratic formula on the resulting, that should say quadratic equate, or on the resulting quadratic term to find the final two roots, which means we have to take x squared minus 4x plus 1, and I got to use the quadratic root formula on there. Quadratic root formula is x equals -b plus or minus the square root b squared minus 4ac all over 2a. And a equals the coefficient in front of the x squared, which is 1. B equals the coefficient in front of the x, which is -4. And c is a constant, which is 1. So I get x equals the opposite of b. If b is -4, it becomes +4. Plus or minus -4 squared minus 4 times 1 times 1 over 2 times 1. Got to simplify it now. So I get x equals 4 plus or minus. Okay, that's going to be 16 minus 4. 16 minus 4 is going to give me 12 over 2. 12 reduces. Square root of 12 is 4 times 3, and the square root of 4 is 2. So it's 2 square root of 3. So I get 4 plus or minus 2 square root of 3 over 2. This only reduces further if the 4, the 2, and the 2 are all divisible by the same number, and they're all divisible by 2. So this is going to reduce to a final answer of 2 plus or minus square root of 3 over 1, or just 2 plus or minus square root of 3. So it said find the roots, or the zeros. The zeros and roots are the same thing. So my zeros are -6, which we got up above, 2 plus square root of 3, 2 minus square root of 3. You can write it like that, and I really don't care if you write 2 plus or minus square root of 3. That would be fine. All right, I will give you the quadratic formula. I will put that on the top of the paper so you don't have to memorize that. I'll put the other ones I said that were law sines and law cosines. And the law of cosines to find the angle. I'll put that, and I'll put the quadratic formula up there. That's I don't have an issue with that. Okay, so that's number 13. I think we have one more from this section. Okay, for the function g of x equals 3x plus 8 over 2x minus 3. Okay, identify what values of x makes the function undefined. All right, it's undefined when the denominator equals 0. So when 2x minus 3 equals 0, which means 2x equals 3 and x equals 3 halves, that means you get a 0 in the denominator. You're not allowed to divide by 0, undefined. So that means x equals 3 halves, undefined. Okay, even though it doesn't say, I'm going to talk about one thing here. So that means our domain are what numbers you can plug in and where it's not undefined, or you get back an answer. It's everything but 3 halves, which means it would be in interval notation, negative infinity to 3 halves, union 3 halves to infinity. This also means my vertical asymptote is at 3 halves. In a vertical asymptote, any asymptote has to be an equation, which means it has to have an equal sign. The vertical asymptote is x equals 3 halves. Okay, so even though I didn't specifically ask for the domain, I wanted to hit upon that as well. That's your domain. Vertical asymptote is essentially where it is undefined. Second part, this can be a little bit trickier. Horizontal asymptote. Let me move this down here so I can see it. Horizontal asymptote is based upon the degree of the function. The degree of the numerator compared to the degree of the denominator. If the degrees are the same, and in this case they are because they both are first degree. If the degrees are the same, all we have to do is use the coefficient, and that will be our horizontal asymptote. And you just take the ratio. So y equals 3 halves, and it always is y equals for the horizontal asymptote. And that's all we need. Now, this is coincidence that it's x equals 3 halves and y equals 3 halves. All right, and I'm just going to run through a couple others here just to make sure you understand this. If they're the same degree, we just look at the coefficients of the highest degree. So let me just throw one up here. If h of x equals 4x squared minus 5, and this one is 3x squared plus 7x minus 2. I'm only concerned about the coefficient here. And so that means my horizontal asymptote is y equals 4/3. If the degree of the numerator is less than the degree of the denominator, automatically your horizontal asymptote is y equals 0. Okay, automatically. We will not worry about, and you probably covered it with oblique asymptotes, but we're not going to worry about when the degree of the numerator is bigger than the degree of the denominator. You will not see that. But you do need to know where they are the same power, okay, whether they're both x squared or both x's. You just look at the coefficients. And then you have to know if the degree of the numerator is less than the degree of the denominator. It's automatically y equals 0. That's part of what you learn. Okay, that is the end of our Unit 9 review. Okay, make sure you go through here, make sure these problems make sense.